It looks like we may have a small crowd today. It will give just another 30 seconds or so, see if anyone else shows up. All right, now let's see here. What have we got going on this week? There's been a lot of movement on pull requests, a lot of new stuff. Quite a few Blue Store pull requests have been coming in for different things, both bug fixes and a fair amount of performance related things. Let's see. There's this first one about garbage collect for partially overlapped blobs. I'm curious to see how much that helps. So that's basically slowing down reads over time, and it's good that we've got that in there. What else is in here? Oh, Sage's. This isn't Blue Store, but this is Sage's PR for less frequently updating certain PG-info-T stats. It turns out that when you look at all of that data that we were updating, it was like 800 bytes for every single metadata update, which is kind of crazy. So this, I think he said, gets it down to something like 190 something. So originally we had been kind of looking at just var and encoding the whole thing, and it'd be a kind of a brute force easy fix. But I think this is actually going to be better. The conditional checks that he's doing here are probably lower overhead than the encoding was. So yeah, that looks good. I'm excited to see how much that helps. We are kind of stupidly using the RocksDB iterator instead of RM range. If for anyone who hasn't looked at RocksDB, the iterators are super slow, so this is good. What else? Separating the KB sync thread into two parts in Blue Store. Sounds like that might give a pretty substantial random rate performance increase, something like 15 or 20%. So that's also really good. Yeah, there's a whole bunch of stuff here that closed as well. Yeah, let's see. There's a number of things here that we closed that have been kind of superseded by other work. The safe and unsafe appender, that's all now kind of changed in the new encode decode PR that is up there. And speaking of that one, that one's kind of going through testing right now. It looks like in the very most recent version of that pull request, we may be seeing a regression specifically with aged random reads, or random reads on an aged system. So we're kind of trying to track that down, and it's a little bit annoying, but hopefully we'll figure that out soon. There was a nice little PR here for changing the shard search from a linear search to a binary search. That's kind of a nice little clever PR. Let's see what else. Yeah, there's a couple of other ones in here, but I haven't looked at them too closely, I guess. So yeah, that's kind of what's been going on this week in pull requests. A lot of movement, a lot of changes, a lot of stuff to test. So let's see, who all do we have here? I guess I've already kind of talked in discussion topics about some of these pull requests and things. I don't know, Sage, is there anything you wanted to add to any of that?
No, I think that covers it.
Okay. Maybe then, since we've got you and we've got Alan here, it might be interesting to talk a little bit about the memory pool discussion that kind of came up on the mailing list.
Yeah, I mean, I think we pretty much agree on requirements. I think it's just a question of how we're going to implement it. How am I send a link to the C-star stuff? I haven't looked at any of that yet. I don't know, Alan, if you know where we should start there.
I'm sorry, say that again, it dropped out.
I don't know if you have any ideas where we should start there, as far as selecting an allocator and putting together a prototype.
You know, I'm not sure there's any way to figure it. I mean, unless these things are showing up at the top of the perfmon, it's sort of pick one. You know, I was fond of the list inside of a buffer. Okay, that seemed like a no-brainer case where you almost always had, one or two members at most. I figured the vast majority, of list members, and you probably save 2 or 3 calls to the mouth.
Looks like you're cutting out. Yeah, I mean, I think this is independent of using the slab allocation for like small vector and slab vector and so on. Yeah, I guess I just don't want us to have to go write anything that we don't have to. So it'd be nice if we just choose. I don't know if we can just instantiate the existing STL allocators or instantiate. Yeah, we lost him. All right, well, we'll probably have to come back to this. Yeah. I don't know if it's possible to just instantiate a standard allocator, STL allocator in class, or if you want to use one of the boost ones and try to optimize it per type. I don't know, but I think simple to start, because I think the biggest thing I want is just the memory accounting. So I can make the back pressure stuff, trim caches based on actual memory used instead of these hard to configure counts. But beyond that,
do you know what kind of Greg's requirements were for his use case?
It's going to be the same across all the code.
Okay.
I don't think it matters that much.
Cool.
Yeah, we just want to define this particular type goes in this particular pool and fix up the allocation call sites appropriately. But I don't think it'll be too bad.
Yeah.
Yeah, I don't know if there's too much to discuss until we look at those options.
In terms of how we budget memory, kind of in a very general sense in Blue Store, where it strikes me that we probably want to be giving RocksDB a lot of cache, I would suspect.
Probably. Yep.
More.
Yeah. Yeah, I think metadata caching is going to be higher yield in general than data caching for most workloads.
Yeah.
But
I guess, I think you're probably right that simple is the right way to go on this, right? I mean, rather than, I assume that RocksDB is going to be doing some of its own caching there, so we're probably not going to need to be.
Yeah, well, we just have to decide how to tune RocksDB so that it has an appropriate amount of memory.
Yeah,
it might be that what we do is change the Ceph configurables, and so they are defined in terms of a fraction of the total cache size that we allocate to RocksDB, so that there's one knob that somebody says, I want the OSD to use 1 gigabyte of RAM or whatever, and then it will. It's smart to figure out how much to give to RocksDB and so on.
Yeah.
But I think that can come later. For now, it's all just sort of crammed into that RocksDB tunable string.
Yeah. I guess I guess kind of where I was going with that is I'm wondering, is there anything in the OSD that we really need to worry about in terms of like, you know, making sure whatever solution we implement here is actually, you know, really good, or is it just kind of a, I don't know. Like you said, I think simple is the right answer.
Yeah, I don't think so. I mean, probably the hardest thing that the OSD is going to do, it's going to be the most sensitive, is that it has these PG logs that are a bunch of OMAP key inserts that are spread out over time in different parts of the namespace. And if you have a OSD that goes down and then comes back up, you have to do backfill. You have to read these logs in. No, I take it back. That happens on startup, so it should be okay. Yeah, no, I can't think of anything.
Are there any other things outside of the OSD that really need this badly? That are
the MDS needs it. I mean, everything, even the OSD outside of the Blue Store needs it. Like, this has always been annoying. Figuring out how much memory the OSD is going to use and tuning it to use that much memory is a black art. So I think if we solve the general allocator problem, then we'll be able to clean up a lot of this stuff.
Okay.
But especially in the MDS, it's pretty bad in the MDS.
Okay.
So anyway, but I think the next step is to continue the discussion on the list. I don't think we have anything we need to go through right now.
Sure.
Let's see, the fast info stuff is just queued up for testing. I don't think there's anything else to do there. I could do some performance tests, I guess, to see how much it helps on File Store and on Blue Store. That should reduce the metadata load quite a bit, but who knows what the performance impact there is. So there's probably some testing to do there. Let's see. That aged random read regression that you're seeing is really weird. I think that's the next thing we need to dig into.
Yeah. I want to go through and figure out if I look at that older branch that I have that I think you hadn't like merged. I assume you merged a bunch of stuff into that one commit. I forget 4.2 something.
Yeah. There's one commit that actually adds new framework, and then there's. I mean, I keep rebasing that branch as I fix things. So, and I pull it up to latest master. So, I'm going to make sure it's bisectable, and once I do that, then I think we can retest on that and figure out where it broke. Because there are a few things that I changed, but I don't really understand why they would have affected it.
Yeah, me either. It seems to be fairly clear though, because I've gone through like 7 or 8 different full tests at different points, and it seems like I'm seeing pretty consistently a one range and another range of results that don't really overlap. So there's variation within each one, but they seem to be distinct clusters. So.
Okay. I don't know. Is there anything else? To discuss?
Not necessarily. Maybe I'll mention that it seems like the stuff that Dan is working on might be important for the async messenger based on how I was saying in the mailing list.
Yeah. I think it would. Yeah.
It sounds like. Yeah. It sounds like we worked fast dispatch harder with async messenger. I don't actually understand that, but.
I think it's because the it used to be that you have a thread per connection that calls into fast dispatch. So if it's a little bit slow, it only affects that connection. Now it's a pool of threads that's handling all of the reads and writes off the socket. And so when fast dispatch slows down, it kind of slows down the whole thing.
Okay.
I'm guessing that's why. That's pretty high level hand wavy, I guess. But yeah, but I think, I mean, even RCU aside, there are some blocks I think we can just remove also that he was looking at first.
Okay. Yeah, if we can sneak those in before the next release, that would be really swell. Not to have async messenger slow things down.
Did you see Zhenpeng's email? His tests are showing the opposite. Basically, he's saying like a 30% speed up with async.
But look at his JMalloc test.
Yeah, but we're not using JMalloc.
I'm wondering though if his other test, if his TC-malloc test was actually started with high thread cache values.
He said no, but
that's the thing, right? Is that simple messenger is really slow in those kinds of tests when you don't have high thread cache.
Oh, I see what you mean. I see. Okay.
So
you're tuning simple messenger accordingly.
Well, as long as you have like 128, it seems like a lot of times simple messenger should be faster than async messenger. That might not consistently hold all the time, but it looks like, at least with JMalloc, which is kind of gives this similar kind of results that you see with high thread cache. In that case, that's where we see simple higher than async. So it's kind of like once the memory allocator is out of the way, however you achieve that, then simple is faster than async.
Yeah.
But if you look, yeah.
All right. Well, I don't think he was doing the inline send encode.
Yeah.
Whatever that switch was.
Yeah.
And inline false.
The other thing is my test was with BlueStore and his was with FileStore, so it might be that there's some maybe either BlueStore is faster and we're hitting this bottleneck faster, or maybe BlueStore is just making it worse somehow. I don't know.
Yeah, maybe. Yeah. Okay. Okay. Well, we should chase that down because there might be too that we can just spend some time profiling it and identify some things we can speed up. I don't know how much that.
Yeah.
How much time is spent optimizing?
Yeah, I've got some results or some perf traces that I kind of was eyeing a while back, but I haven't really dug into them. Yep. At least in that respect, looking at the messenger stuff.
Okay.
One question I had for you, Sage, speaking of perf, is in those traces that you were getting recently, did you see anything related to the bitmap allocator? Because that was still
almost
showing
nothing.
Huh.
I still don't trust my traces because they look completely different from yours and they show no detail. My only theory was that maybe my compiler version is more aggressively inlining, and so I don't see a lot of the tail ends of the call chain. But I don't know. It's really weird that when I look at your profile, I'm like, oh, I can fix this and this and this, and when I look at mine, there's like it doesn't. There's nothing to do. So, I don't know. I don't know. I think let's get the encoder stuff sorted out, and then I'll spend more time on that again. I have a couple of things I gotta fix first, but
sure.
I'm sorry to get antsy about getting Kraken fixing upgrade tests and getting other stuff cleaned up to merge.
Yeah.
I want to get the encoding stuff in.
Yeah. So. The only other thing I had in here too that it's not exactly perfect related, but I wanted to mention that you had started getting the BlueStore going through the topology tests.
Yep.
That's exciting.
Yep. The last one. I'm fixing a memory. I'm tracking down a memory leak right now. It's a stupid one on the mirroring stuff. So, yeah.
Cool.
Okay.
All right.
All right. Well, I'm gonna go.
All right.
If you want to resume, if you want to resume the discussion before my cell phone went crazy, we can try
it. Sure. Yeah, I was just saying that I think we should avoid writing any allocator if we can, and just use something that already exists if possible. Like one of the boost pool.
We could find something that gets the job done, yeah, but none of the things that I've found so far really seems to cut the mustard.
I mean, there's
the boost pool is all about multiples of the same object type, which sort of doesn't really solve any problems for us.
Yeah.
And there's some other kind of low-level stuff, but I think a lot of it resolves around being able to save the container code that we've got. I think once you sort of treat that as a prerequisite, then you're dealing with an STL allocator, and they're not that hard fundamentally.
Yeah, well, I mean, I don't think the STL allocator piece is difficult. Any allocator we can wrap up in the STL allocator class, but but allocators in general are very difficult to write. I don't want to write our own allocator.
Agreed, and I wasn't proposing that. I was proposing adding a layer of accounting around the existing memory allocation framework. All of the underlying allocations is still malloc and free. There's no way I was going to have absolutely no intention of touching the memory allocation. Okay, I'm just going to keep track of some stats. And
so you're just thinking like a per CPU atomic or something.
Exactly.
Okay.
Yeah, I was going to take like I think it's the pthread ID, which is actually the root of the call stack, and use a few bits out of that to index into a shard, and that would be my per CPU atomic. And
can't we just use declare it a thread local variable and have it an array of atomics that's per CPU? Or thread local,
but then the question is so how do you get to somebody else's? I mean, you still want to be able to globally say at the end of the day, how much am I using across all the CPUs? So, and then you run into the problem that that the allocator is not going to match the destructor. Okay, so the scheme I was going to use would end up with a bunch of atomics that might go negative, but you have to add them all up. You know what I mean?
Yeah.
Because you might increment in one thread and decrement in another thread, and I'm sort of not going to care about that. But the issue at the end of the day is you have to find all of those things. And you're right, you can make it thread local, and that might be the right thing to do. But now the question becomes, we don't have a common place of capturing all the threads. Is the problem.
So this is something that the kernel does all the time. There's a whole library for doing this that sums up all the things across CPUs and everything. There's got to be a C library that does the same thing.
I think there's
a register that tells you which core you're on, right? It's it should be built on the same infrastructure.
No, not at all. The pthreads library does it. I mean, it does mallocs to create stack threads, and your local storage is just sort of hung off of that, right? I mean, I agree. The library should sort of know where everything is, but if it doesn't have an interface to it, what do you're kind of out of luck. And I think the the whole per thread stuff, I don't know that the kernel knows anything about that. Just another register he swaps, right?
Yeah, but we don't care about threads either, though. We just want per core. All we want to do is avoid hammering on the same atomic from different cores.
Yeah, but if you base it on, well, so the question is, so how do you figure out which core you're on?
Yeah, it just seems like there should be a register. Like you should just have a.
Well, but there isn't. It's not in any register. Okay, it's not in user space. It's fundamentally ambiguous. Okay, if the minute you ask the question, it's wrong.
Yeah.
So I don't. There isn't really a good reason to have that. So what I was going to use is, all I care about is some identifier with some affinity to the CPU. So what I was going to propose is basically the base of the stack frame, which is what I think the pthread. I forget, it's the pthread ID or the pthread name or something like that. But it's a cheap thing that you can get. That it's just disambiguating. That's all I really care about. It just needs to be
I'm just
something cheap, something really cheap you can get that will spray it around. For that matter, I could just take the current frame pointer or the address of a local and pick it off of that. Pseudo-random's good enough. Okay.
The issue is
just that it's the cache lines stuck. I think you want to keep those cache lines local. That's why I was going to use the base of the call stack, figuring that once you faulted it in, you wouldn't have a context switch for a while.
Yeah, but if a thread ever moves to another core, then
you get one fault until the next switching interval.
Yeah, I guess, and you just make it big, so it's much larger than your number. Your CPI count might be, your core count might be 32, but you have like 1,000 of these.
Yeah, exactly. And then you pay the price to add them up when you ask the question. Okay. And if you only do that infrequently, then it's not too bad. I was figuring 32 or 64, but I think that I think that's probably plenty of disambiguation. It probably only really needs to be like maybe 2 or 3 times the core count that that this OSD is scheduled against. What it really says is you probably want to partition your cores against your OSDs.
Yeah.
Okay. Once you do that, then the need for this to be big goes away.
Exactly. Yeah. Okay.
Anyways, those were my thoughts. And it's pretty straightforward code. It's the usual rigmarole that you got to think it right, and then it's only a few lines of code at the end of the day.
Right. So I guess the requirement is that we need an STL allocator class that we can feed into the containers.
Right, which I kind of have with the slab. I was going to take the slab stuff I've done, which is sort of basically a beginning of that, and just keep extending it.
Okay, but we also need the individual call sites for new. Also need to do the same thing.
Yeah, I was going to do that with kind of a macro kind of thing. I think the easiest hack would be to basically make your new and delete be the equivalent of an intrusive list. And then you just put one of those per type in the container. Something like that. That kind of hack doesn't really matter, I think. Again, the core is as long as you're not mucking up the path to malloc and free significantly. I think we're looking at an atomic increment after some shifting and masking to pick one. Which with some affinity to the current core. I'm guessing the netted out should be a dozen instructions or something like that, times whatever the effectiveness of the sharding is on the cache miss. I think that's going to be the total pain you're going to see on it.
Right.
The cost of the construct and the delete. I guess. I guess what I'd say is let's make it a compile time option. I think there's a lot of value in having introspection into what's going on inside
as long as it can be built up. Yeah.
Yeah, and and we can just kick the question of whether or not that overhead is too much. We just kick it down the road. It's trivial to disable with a compile time switch. And whether we leave it on or not, we'll figure that out later.
Yep. Okay. Sounds good.
All right. Okay.
All right. I'm gonna go to work.
All right.
Okay.
See you later, Sage.
See you guys later.
Okay. Bye.
All right, guys. Would anyone else like to bring up anything this week before we retire? All right. Well, then I will get back to work as well. Everyone have a great week, and we will reconvene next week. Thanks.